Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8-point DFT using DAT algorithm, the basic steps followed in this computations. Look at the butterfly structure. This is an 8-point DFTs, so using DAT algorithm structure. Look at this. This is X of 0, X of 4, 2, 6, 1, 5, 3, 7. This is the bit reversal order. So input is bit reversal order and output is natural order. Look at this. X of 0, X of 1, X of 2, X of 3, X of 4, X of 5, 6, 7. This is natural order. We have tittle factors. 4 tittle factors we are using. So this is W08. So all 4 we have this W08. So first stage, so we have a 4 butterflies. This is 4 butterflies have the same tittle factor of W08. Look at this second stage, it consists of 4 butterflies. So these 2 butterflies and then these 2 butterflies. So these 2 butterflies, the tittle factor is this is W08 and this is W28. Here also same, that is W08 and W28. Look at this last stage, we have 4 butterflies. The tittle factors will be entirely different. This is W08, W18, W28 and W38. So this is the butterflies tittle factors for the each butterflies. So it consists of 3 stages. Each stage is consists of n by 2 butterflies. That is a 8 by 2 is a 4. So each stage it consists of an 4 butterflies. Look at the steps followed in this. So first step, the number of input samples n must be a 2 power m. So m must be an integer. So if you put an m equal to 0, 2 power 0 will be 1. And if you put an m equal to 1, 2 power 1 will be 2. So that is a 2-point DFTs. If you put m equal to 2, 2 power 2 it will be 4. So you take a 4-point DFTs. And if you take an m equal to 3, so 2 power 3 will be 8. So we have an 8-point DFTs. If you put an m equal to 4, so 2 power 4 this will be 16. So we can consist of 2-point DFT or a 4-point DFT or a 8-point or 16-point. So in between points not allowed. So for FFT computation, the input samples must be in this range n equal to 2 power m, where m is an integer. So second point, the input sequence is shuffled through bit reversal. So DAT algorithm input is bit reversal. So the input sequence is shuffled through the bit reversal. So bit reversal is nothing. We need to write the binary equivalent. For example, I am taking a 1. So 1 binary equivalent is 0, 0, 1. If you reverse it, 0, 0, 1 becomes 1, 0, 0. So 1, 0, 0 is 4. So instead of 1, that will be changed as an 4 here. The input is bit reversal, output is natural order. Look at this. The number of stages in the flow graph is given by m equal to log base to n. So log base to n. So if you take an 8-point DFTs, so log base to 8 will be taken. So log base to 8 is 8 can be written as a 2 into 2 into 2. So that will be m will be equal to, so we take it will be a 3. And then look at this. Each stage consists of an n by 2 butterflies. So capital N is 8-point means 8 by 2, that will be equal to 4 butterflies. So if you take an 8-point DFTs, it has 3 stages. Each stage it consists of an 4 butterflies. Look at this. The input and output for a butterfly is separated by 2 power m minus 1. So where m is represented as the stage index. So stage index is for a first stage m equal to 1, for a second stage m equal to 2 and third stage m equal to 3. In vice versa it will be continuous. So this will be decides this number of input samples. So if m equal to 1 means 1 minus 1 is 0. So 2 power 0 is 1. So this will be separated by 1. So based on this m value, the number of inputs separated will be changes. Look at this. The number of complex multiplication is given by n by 2 log base to n. So normally if you take an DFT computations, there we require a n square complex multiplication and n into n minus 1 additions. But if you take an FFT, this much multiplication is reduced. Look at this, n by 2 log base to n, that much of multiplications is reducing. And look at this, the number of complex addition, see this will be given by n into log base to n. If you take a normal DFT computation, it will be n into n minus 1. That will be reduced here as n into log base to power n. And then the tittle factor exponents are the function of a stage index m is given by, look at this, k is equal to n into t divided by 2 power m, where t is equal to 0, 1, 2 up to 2 power m minus 1 minus 1. So that means the tittle factor exponents will be changes. So it will, we need to substitute for the different values. For example, if you take an m equal to 1, so 2 power 1 minus 1, so 2 power 1 minus 1 will be 0, 2 power 0 is 1, so 1 minus 1 is 0. So only t equal to 0 we need to substitute it. If you take an 2, so 2 means, so 2 power 2 minus 1, 2 minus 1 will be 1, 2 power 1 is 2, 2 minus 1 is 1. So we need to substitute t is equal to 0 and then t is equal to 1. Now if you take a 2 power 3, so 2 power 3 minus 1, 3 minus 1 is 2, so 2 power 2 will be 4, 4 minus 1 is 3. So now we need to substitute that value t is equal to 0, 1, 2 and 3. So these 4 values we get it. Inside this, if you substitute it, for first time we will substitute here, we get only the 1 value here. So n into t divided by 2 power m. So m is a stage index. So for example, if you take a last stage, m equal to 3 we are substituting here now. So 3 minus 1 is 2, so 2 power 2 4 minus 1 is 3. So in this case, so 0, 1, 2, 3 to be substituted. So m is 2 now, so 2 power 2 will be 4. Capital N is 8. So 8 divided by 4 into t we need to substitute it. So if you substitute 0 here, so 0 into anything that will be becomes 0. So first stage will be a W08. If you substitute 1 here, so what happens? So this will be a 2 by 2 4 and this will be a 8 and this will be 1. So we get an 8 by 4. This is 1 by 2. So similar values we need to substitute and we get the Tittle factor values. Look at this. This is the number of sets of or sections of a butterfly in each stage. So that will be given by the formula of 2 power capital M minus small m. So where capital M is the first one, this is the capital integers, and then the small m is the stage index. So this is 0, 1, 2, 3, it will be continuous. And then ERP, this is exponents repeat factor, so which is the number of times the exponent sequence associated with m. It represented by 2 power m minus m. Thank you.